Hello, welcome to Z Talk. This session, I'd like to start a new topic, Docker. As a DevOps engineer working on microservices architecture, containerization is an important step under continuous deployment DevOps lifecycle. And Docker is one of the most popular technologies for containerization. So I'd like to kick off this new series of sessions to explain the foundation of Docker. Firstly, let's understand why do we need Docker. Here it's a flow of probably a process every one of us has gone through when we install softwares on our computer. We download an installer, run that installer, and then inevitably at some point in time we ended up getting an error message during installation, so we have to troubleshoot and fix the issue and rerun the installer. And we might run into another issue, so we're back to the loop to fix the new issue came out until we are able to install the software successfully on our laptop. So this is at its core what Docker is trying to fix. Docker wants to make it really easy and straightforward for us to install and run software on any given computer or cloud-based computing platforms. Okay, let's start here. I will give you a real quick demo of installing Splunk by Docker on my laptop. As you know, without Docker, the normal procedure of installing Splunk requires you to download the installer from Splunk website and then transfer the installer to the servers or VMs where you plan to host the Splunk application, and then unzip the installer and run it, right? Which is kind of tedious. And what's worse, let's consider a scenario where we trying to build a real Splunk infrastructure, which includes multiple servers. For example, let's say we gonna build a standalone search hat, three indexers as index cluster, and one cluster master, which also acts as license master and deployment server. In this case, so we have to prepare 5 VMs ahead of time and perform the same procedure of installation 5 times on each of servers. It's really a tedious procedure, as when we are dealing with even a larger infrastructure, it's gonna involve more servers, which means we have to do the same procedure again, again, and again, right? Now with Docker, we can fulfill these use case really quick on one single host. Let's test it out on my laptop. Let me jump to my browser. Uh, Basically, all I need to do is to go to Docker Hub to grab the Docker image for Splunk. Basically, you can consider Docker Hub is a public repository of different kinds of Docker images. Here is the search bar. In the search bar, just search for Splunk, and here we go. We got the page where Splunk image is stored, right? So here is the command we gonna use to download and install Splunk image to our local laptop. For now, don't worry about the syntax of these command, as we're gonna go through all of these important Docker CLI commands along with these series of sessions. For this demo, I just want to quickly show you what is Docker capable of and what benefit we can get out of this technology. All right. So before I install run this command on my terminal, so I need to do some modification because for my scenario, I'm gonna install multiple container or multiple instance of Splunk on my laptop. So I need to do a little bit change. Again, don't worry about the syntax of these Docker CLI commands. We will go through it later. All right. And by the way, I already installed Docker ahead of time on my laptop. I'm on my Mac OS, so I use Homebrew to install Docker, which is the easiest way. So you can follow the documentation to install on your end. All right. So let me run this command first. So again, don't worry about the syntax with these commands. So I will explain like step by step a little later, right? So let me run this command first. So basically here I just set a default password for the admin user as this one, but just for demo purpose, right? And what you can see, what happened was like it did not find the image of Splunk on my local laptop, so it started downloading the image from the GitHub repo. Sorry, not GitHub repo, the Docker hub. So now the download a new image for Splunk was done, and let's take a look. Docker PS. You can see there's a container, basically an instance of Splunk already up and running. So what I need to do, I just need to go to a browser and do localhost, and port. Here we're using port 8000, right? So I just issue 8000, hit enter, and here we go. This is the Splunk interface, right? So let me go to issue admin, and I just issue the password, which I said is 1 2 3 4 5 6 7 8. All right, 1 2 3. Sign in. All right, I'm in. So you see how quick it is to install a Splunk instance by Docker. And now, since we're gonna create multiple instances of Splunk on the same laptop, so next I'm gonna run that again, the command again. This time I'm gonna do a little bit change. So I will run this command. So if you notice, basically I just changed the name of this instance to differentiate the role of this instance. This one is gonna be the index master, right? And this one gonna be a index. And the host name is index2. And this time I use another port to run this instance. Instead of 8000, I'm using 8001 to run this instance. The rest is same. Let's hit enter. You can this time, since the Docker image of Splunk I've already downloaded to my local last time, since this is the second time, right? So this time is even faster because it does not have to download it again. It's already stored on my local. All it does is to grab that image and create another instance of Splunk. Let's run that Docker PS command again to see how many containers are running. Now you can see there are 2 containers up and running in my local host, right? So one is using port 8000 and the other was using 8001. So let's test it out. So here, let's go to localhost and 8001. Hit enter. Here we go. So this is another one instance. 1 2 3 4 5 6 7 8, and sign in. So now you got an idea how quick I can build up these Splunk infrastructure. So since the instance already built up, so we can continue on the regular configuration to assign each of instance of its role, like index master or indexer or search head. All right. So I just give you an example. I won't build up all 5 instances, but it's already a good example to have you understand how quick I can use Docker to set up these Splunk infrastructure, comparing with the traditional way of building Splunk infrastructure. All right. All right. Now back to my presentation. I think we had a better understanding now with the use case of Docker installing Splunk. Now let me try to explain what is Docker. Generally, Docker is the platform or ecosystem around creating and running containers. I guess your immediate question back about it is, what is the container then? Well, a container it's an instance of an image. You can think of it as being like a running program. We're gonna go into great detail about it, but right now all we need to understand is that a container is a program with its own isolated set of hardware resources. So it owns its own little set of space of memory, space of networking, and also space of hard drive, right? Back to my terminal and for my previous demo. So as you remember, I ran these commands to initiate an instance of Splunk on my local computer, right? So basically what happened behind the scene after I issued this command, Docker CLI reached out to Docker Hub, which is the container repository, and it downloaded a single file called an image. And image is a single file that contains all the dependencies and configuration required to run a program. In my case, it was Splunk. All right. Now let's take a pause here and install Docker on your laptop if you haven't done so by following the instructions on Docker's official documentation. Let me go to my browser, and here are. Just follow the instruction. Here it provides the instructions for installing Docker on different flavor of operating systems like Mac, Windows, Linux. Follow the instruction, and it's pretty straightforward. Basically, the first tool, let me go back to my PPT, and basically the first tool that's inside of these install package is something called Docker client or Docker CLI. Basically, is the component we use to interact with Docker server. And on the other hand, Docker server is actually the tool that is responsible for creating images and running containers. All right. So now I assume you had Docker installed on your laptop. Let's test it out by running the simplest application. Let's run Hello World. All right. So let me go back to my terminal, and let's just issue Docker run Hello World. Let's see what happened. Do not exist. Okay, let me do Docker run Hello World. There was a typo there. All right, there was a list of actions happened real quick. For a better understanding what just happened behind the scene, let's go back to my slides real quick, and I basically draw like a diagram to show you or explain you what happened just now. All right, so after I issued the Docker run command, it started up the Docker CLI, Then it communicated the commands over to Docker server where the real heavy lifting happens. We wanted to start up a new container using the image with the name of Hello World. This simple image has the tiny program inside of it. All it does is to print out the message we saw right here in my terminal, right here, hello from Docker. All right. So when I issue that command over Docker server, there were a serious action happened. The Docker server saw that we were trying to start up a new container using an image called Hello World. The first thing that the Docker server did was to check if it already had a local copy of that image. If not, it will connect to the Docker Hub, which is the public image repository, to find that image and download it to the local location called image cache right here. All right. So once they got the image, Docker server said, okay, I've got the image. Now it's time to use it to create a container. As you remember, it's basically an instance of that image, right? So now let me give you a behind scene look at what a container is and how it's created on your machine. All right, but before that, let's have a quick overview of the operating system on your computer. So firstly, the operating system has the kernel, all right, which is a running process that governs access between all the programs or applications that are running on your computers, and also all the physical hardware that is connected to your computer. All right, and these running programs interact with the kernel through something called system calls. All right, and these are essentially like function invocations. The kernel exposes different endpoints to say, like, if you want to write a file to a hard drive, right? Just use this system call, something like that. So now, after understanding the structure of our operating system, let me introduce you to important technology for a Linux-based system. So because basically they are the foundation of containerization, all right? So the first one is called name spacing. We are allowed to isolate resources per a process or a group of processes. So anytime these process asks for system resources, we're gonna direct it to a specific dedicated area of a given piece of hardware. Very closely related to the idea of name spacing, there is another feature called control group, or you can call it C groups, which is used to limit the amount of resources that a particular process can use. So naming spacing is like declaring these area of hardware, hard drive, is designated for this process. And a C group is used to limit the amount of memory or CPU that these processes can use. All right? Okay, now I guess you can imagine this entire section, this entire vertical section of a running process plus these segment of resources that it can talk to is what we refer to as a container. A container is it's really a process or set of processes that have a group of resources like RAM, CPU, network, hard drive, specifically assigned to it. All right? Cool. We understand what is container. Now, what about an image? All right? It's really about, for image, it's really about a file system. It's essentially kind of a copy paste of a very specific set of directories or files. For example, an image that contains Splunk and its required Python environment. Also, an image contains a startup command to run Splunk. Here is what happened behind the scene when we take an image and turn it into a container. First off, the kernel is gonna isolate a section of hard drive and make it available to just this container. So the file snapshot of Python and Splunk is taken and placed into this section of hard drive. The startup command then is executed like run command, run Splunk, right? So Splunk is invoked to the kernel, and we created a new instance of that process. And this Splunk process is then isolated to this set of resources right here. That's pretty much it. That's the relationship between image and container. And that's how I was able to build up multiple Splunk instances in my previous demo on one single machine, right? Basically, it's using that two features, name spacing and control group, C group, all right? And please note, again, these feature of name spacing and C group are specific to Linux operating system, not Windows nor to Mac OS. So how do we run Docker on Windows and Mac? Well, when we install Docker for Windows or Mac, actually what we did is we install a Linux virtual machine on top of our Mac or Windows operating system. So inside of the virtual machine, that's where these containers are going to be created. All right, cool. That's pretty much what I want to share in this session. Hopefully, you didn't get bored of this long presentation. So next session, I will go through more demos on the Docker CLI command to show how do we manipulate containers with the CLI. All right, cool.
All right, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.